flash of fire and stone, a world was born. And everything we know would later rise from that first blaze. Imagine a sphere of molten rock, churning under a sky of darkness, where every second could reshape destiny. In the next 10 minutes, we will travel across 4.5 billion years of relentless change, from the moment Earth was a searing furnace, to the breath of the first single-cell spark, to the thunder of the dinosaurs, and finally, to the quiet whisper of humanity. Hold tight. The story of our planet is about to unfold. I am your guide, and together we will move through the ages as if turning the pages of a living book. First, we begin when the sun ignited, pulling dust and gas together into a swirling disk. Gravity gathered the particles, and the young Earth grew, colliding with countless space rocks. One massive body, the size of Mars, slammed into the newborn world. The impact hurled debris into orbit, and within weeks that cloud coalesced into the moon, a permanent scar and a silent witness to the chaos. The planet's surface was a sea of lava, spewing rivers of fire that reshaped continents in moments. Volcanoes erupted without pause, filling the air with ash and vapor. As the planet cooled, steam rose, condensing into rain that fell for the first time. Oceans formed, covering the scarred crust, turning fire into water. From that primordial soup, a thin veil of atmosphere settled, still toxic, still unbreathable, but a cradle for what would come next. Deep beneath the black water, its heat met mineral-rich vents. Here, chemistry sparked life. A simple cell clinging to energy, like a candle in the dark. These early organisms built mats on the sea floor, forming stromatolites that rose like ancient reefs. Their tiny structures recorded the first fingerprints of biology, evidence that life could endure in a hostile world. Then a green revolution began. Cyanobacteria learned to capture sunlight, releasing oxygen as a byproduct. Slowly, the seas turned from a deep crimson to a pale blue, and the atmosphere filled with a gas that would later allow animals to breathe. This oxygen flood was a double-edged sword, poison for many early microbes, but a catalyst for complexity. The planet froze over in a global glaciation, a snowball Earth that seemed to halt all progress. Yet life persisted in pockets of heat, clinging to underwater vents, waiting for the ice to melt. When the climate finally warmed, the stage was set for a new explosion of forms. Carbon-rich forests swamped the continents, locking away vast amounts of carbon and shaping the climate for ages. From these verdant jungles emerged the first reptiles, and later, the giants that would dominate the planet for millions of years. Their reign built the iconic silhouettes we picture today: towering sauropods, fierce tyrannosaurs, and the soaring pterosaurs that ruled the skies. But the world was not static. The supercontinent Pangaea began to split, carving new oceans and reshaping habitats. This tectonic ballet created isolated ecosystems that sparked further evolution. Then, in a moment that would end an era, a colossal asteroid struck the western shore of what is now Mexico. A 10-kilometer rock slammed into the sea, sending firestorms across the globe, blanketing the sky in darkness for months. The dinosaurs fell, and the world fell silent. In the quiet that followed, small mammals that had hidden in the shadows for eons seized the opportunity. They grew larger, smarter, and more adaptable. Ice ages came and went, carving valleys, shaping coastlines, and testing the limits of survival. Through these cycles, the ancestors of our species emerged, learning to make fire, to craft tools, to paint stories on cave walls. All of this began with a spark in a volcanic vent, and all of it leads to us, standing on a planet that has survived fire, ice, and impact. If this journey is opening your eyes, hit that subscribe button and join DNA Explained so we can keep uncovering the secrets of life together. But the story does not end with us. The Earth still breathes, still shifts, still writes new chapters in stone and gene. Humanity has become a force of change unlike any before. We have tamed fire, forged steel, split atoms. We have lifted the sky with rockets, stitched genomes with CRISPR, and mapped oceans from the depths to the satellites overhead. Yet with that power comes responsibility. The climate that once cooled the world into a frozen globe now warms under our influence. Carbon that was locked for millions of years is released in a breath of industry. Glaciers retreat, sea levels rise, storms grow fiercer. Species that survived asteroid blasts and ice ages now vanish in centuries. The very oxygen that once ignited complex life can become a toxin when the balance tips. What will the next era look like? Some scientists picture a world where forests give way to deserts, where reefs become ghostly skeletons, where new microbes evolve to thrive in altered oceans. Others see a future where humanity learns to steward the planet, where renewable energy restores balance, where rewilding brings back lost giants. The Earth's resilience is legendary. It has rebuilt continents, repopulated seas, and birthed life after every cataclysm. Our choices will determine whether we become the architects of a new flourishing or the footnote of a decline. Look up at the night sky. The same stars that ignited the nebula that birthed our sun still shine. Their light, traveling across eons. Those photons spark the chemistry that formed the first droplets of water on a young Earth. Those droplets became oceans, and the oceans nurtured life. The story is a loop of cause and effect, a chain that stretches from stardust to consciousness. Consider the tiny microbes that hid in hydrothermal vents, the first to harness chemical energy. Their descendants became the plants that turned sunlight into sugar. Those plants fed the insects that pollinated them, which in turn fed the reptiles that grew into the giants of the Jurassic. Their bones turned to stone, their fossils whispering secrets to paleontologists. Those same fossils guide us in understanding climate patterns, mass extinctions, and evolutionary bursts. Every rock, every fossil, every gene is a page in the planet's logbook. Now imagine the next page we will write. It could be a record of cities reclaimed by forests, of coral reefs reborn through assisted restoration, of a balanced carbon cycle thanks to innovative agriculture. Or it could be a record of deserts expanding, of ice caps disappearing, of oceans acidifying beyond the tolerance of current marine life. The pen is in our hands, but the ink is the Earth itself. What do you think? Is humanity ready to become a guardian rather than a conqueror? Can we learn from the countless cycles of destruction and renewal that the planet has endured? Share your thoughts in the comments below. Your voice adds to the chorus of minds shaping the future. Remember, the timeline we have just traversed is not a static museum display. It is a living, breathing continuum. The same forces that forged continents will continue to move plates, to raise mountains, to open new seas. The same physics that caused the impact that ended the age of dinosaurs still governs meteor showers that pepper the skies. The same chemistry that produced oxygen will keep cycling through plants, oceans, and the atmosphere. As we close this rapid voyage through 4.5 billion years, let the awe linger. Feel the weight of every epoch, the pulse of every extinction, the spark of every innovation. Let it inspire you to look beyond the present moment, to see the Earth not as a resource, but as a partner in an ancient dance. If you felt the planet's heartbeat in these 10 minutes, let that rhythm guide your next steps. Like this video, if the journey moved you, share it with friends who love the mysteries of our world. And remember to subscribe, because the story never truly ends. It only deepens. Join DNA Explained, and together we'll keep peeling back the layers of time, one revelation at a time.